Hello, Miss. Today I will demonstrate our RSA digital signature simulator. This program clearly shows the three main security features of coding signing: data integrity, origin authentication, and non-repudiation. As you can see, the interface is divided into three sections: key generation, sender operations, and the receiver operations. So now let's start with the step one, key generation. When I click this button, the system generates two large 512-bit prime numbers, P and Q, and uses them to create a 1024 bits modulus N. It also generates the public exponent E and private exponent D. The sender in part 2 automatically receives the private key, while the receiver in part 3 receives the matching public key. Now, as a sender in part 2, I will upload the original text file. The system immediately uses SHA 512 to create a unique digital fingerprint called HA. Next, I click Sign HA. The system calculates the hash power D mod N using the sender's private key and creates a digital signature in hexadecimal form. This signature is then sent to the receiver. So now, let's look at our first test case, a successful delivery. The receiver uploads the file. And the system generates its fingerprint, HB. Using the correct public key, we click Recover HA to retrieve the original fingerprint from this signature. Finally, we compare the two hashes. It shows perfect. Verification successful. This proves that the file is authentic and has not been modified.
Next, let's see what happens if an attacker changes the file during transmission. We will simulate a man-in-the-middle attack. So I will open the original document and change the transfer amount from 1,000 to 9,000 and save it. Then, as a receiver, I upload the modified file. Because of the SHA-512 domino effect, changing even one character creates a completely different hash B. So when we click Final Comparison, the system immediately detects the mismatch and displays a warning. The data integrity attack is successfully detected. Finally, let's demonstrate another scenario. What happens if someone tries to use a fake public key? Since the public key fields are editable for testing, I will change the last character of modular N to F. Now, watch what's happened when I try to recover the hash. Because the key is not longer valid, the recovered hash A becomes completely different and meaningless. As a result, the verification fails. This demonstrates the origin authentication provided by RSA digital signature. Our Java simulator successfully demonstrates how RSA digital signatures provide data integrity, origin authentication, and non-repudiation in real-world systems. Thank you for your watching.